So let's say you're given this function. If you think about the function's domain, you know that when x and y are both 0, the denominator is not defined, and therefore you can't have this fraction. You can't have 0 in the denominator. And otherwise, it's okay. The only time that this denominator is 0 is when x and y are both 0. Okay? Now there's a way to see that the actual value of the function is between -1/2 and 1/2, but that's some tedious algebra, so I don't want to show that to you. But here's the question. I want to know the limit of this function as x and y gets closer and closer to 0, 0, which is the prohibited part. Okay? Now, I really don't have an idea of what this function is, but I mean, it's some kind of surface over the xy plane, right? X and y, you know, z. For example, if I plug in 1 and 1, that's 1 over 2, right? That's 1/2. So 1 and 1, at 1 and 1 you have positive 1/2. And if I plug in 1 and -1, that's negative 1/2. So at positive 1 and -1, you get under it. So over here it's up by 1/2. Over here it's negative 1/2. So that's what you get. And the question is, you're trying to come to this point 0, 0. As you're approaching 0, 0, you want to know where this value of z, if I set this as z, where this value z gets closer and closer to. Now, in one variable case, all you had to worry about was whether the left limit is same as the right limit, right? If they're different, then we say the limit does not exist. If they're equal, then we say the limit exists. Here, the problem is much more complicated because you can approach 0, 0 from here or there or there or there. Right? And therefore, it's really hard to think about all the cases, how this limit would be. Now, the easiest case is when you actually have two directions where the limit is different. So let me show you this case. If I have the r of t as 0, t, what's that? That's like on the xy plane, you're always on the y-axis, right? And then if you send t going to 0, that's like approaching 0 either from here or there, right? So that's one way to approach 0. Another way to approach would be t, 0, right? Which is, in this case, you'll be approaching this way, right? Now, at the first sight, it seems the limit is 0 because if I plug in 0, t here, you get the top as 0, and bottom as t squared, right? And you have 0 over t squared. Right? Same thing as t, 0. If I put t and 0, it's 0 over t squared. So again, you always get 0. So for these two cases, the limit is 0. However, if you think about it, you can also approach 0 diagonally, right? Now, can you think about what this path is? What kind of path is this one? Can you come up with a parameterized version of that path?
X equals y.
Y equal to x is the line, right? But can you parameterize it using t?
T equals x, t equals y.
Yes, x equal to t, y is equal to t, so you get t, t. That will be when you're approaching from the diagonal direction, right? If you do that, then look what you have. So on the path rt t comma t, you have limit x comma y going to 0 comma 0 equal to limit t going to 0, and because you're setting x as t and y as t, you have t times t over t squared plus t squared. And in that case, it's t squared over 2t squared, limit t going to 0, and then this is always 1/2, right? So when you go this way, it's always 1/2, and what does that mean? That means the limit is 1/2, isn't it? And that limit is different from this. For these two cases, the limit was 0. Now let me show you something else. What if you have rt equal to t comma negative t? What kind of line is this one? What's the t comma negative t? What path is it? It's the other diagonal, right? Yeah. So you're trying to approach from this way. On here, the limit you get is t going to 0, and you're setting x as t and y as negative t. And in this case, you get negative t squared over 2t squared, which is negative 1/2. So definitely, you have one direction giving you positive 1/2, another direction giving you negative 1/2. Therefore, the limit exists or does not exist? Which one? Does not exist. Okay? Yeah. So this teaches us this important fact. When you're thinking about limits of a multivariable function, not only you have to consider the limits in just x direction and the y direction, you also have to consider all infinitely many different directions. And if any one of those is different from the other ones, then the limit doesn't exist. So it becomes a very, very tough problem sometimes. Now, there are cases where this question is easy. That's the case when your function is a polynomial. Because if the function is a polynomial, we know that the graph is connected. There's no like steep points anywhere. It's all connected and smooth. So in that case, so for example, if you had like x squared plus 5xy plus y, and you wanted to know limit of fxy, and x comma y goes to 3 comma negative 1. In this case, for continuous functions, we learned that the value of the function is equal to the limit to the function, right? That's what continuous means, right? So you have f of 3 and negative 1, and you simply calculate this. This is 9 times 5 times 3 times negative 1, that's minus 15, and negative 1, so it's negative 7. So for continuous case, we don't have to worry about all this. Just by using the continuous property, we can just evaluate the function and that's it, right? Now there is a third case where limits are not that hard to figure out, and that's the case when your function is really as if it's a function of a single variable. So think about the following. If I had x squared plus y squared, and then x squared plus y squared squared plus 5. No, I can't do that. Sorry. I should put it. Okay, let's put it here. Suppose I have. Well, that doesn't make any sense either, but. All right, so let's do this. That's a good one. All right. So suppose I had limit of x comma y going to 0 comma 0, and you have sine of x squared plus y squared over x squared plus y squared. in this case, I know that no matter what you do, when you take the path going to 0, 0, x squared plus y squared will be going to 0. And because these are both the same thing, we can just replace this limit as, if I set t as x squared plus y squared, so this is like a change of variable. Okay? This t is not a parameter, I'm just doing a change of variable. If I do sine of t over t, and then t would go where? Huh? It would go to 0. If x comma y is going to 0, 0, t would also go to 0, right? So in that case, the limit would be 1. So there, this third case is when you can do a substitution, because even though it's a multivariable function, somehow you have something common in everything, so that you can do a substitution. Okay? So that's the third case when you can easily calculate the limits. But otherwise, if you have a function which is not continuous and you're taking the limit towards to a point that's not continuous, it becomes really hard to determine. Okay? It becomes a tough issue.